Okay, let's take a look at expected value. This is a process that insurance companies use to determine insurance premiums. It's also how businesses can determine whether a particular venture is worth the risk of pursuing or not. Here's a kind of simple, relevant example for college students. Suppose that a company is willing to give you $200,000 a year if you have to quit school, and it's only going to cost you $50 a year. Since the likelihood of that is pretty small, we're going to say in this example that only 1 in every 5,000 students would need to quit college. That means the probability of the event is 1 in 5,000. So if we say that the event is it's going to cost the insurance company $200,000, but the probability is only 1 out of 5,000, the insurance company has an expected payout value of $40 for every student that is actually taking out the policy. So over the long run, it's really not going to cost them that much. So if they can get students to pay $50, that means they're going to get a profit of $10 on a policy. If they can get 400,000 students to choose this, they're going to make $4 million just from this simple little thing and not have a lot of payout. Okay, so let's look at some more definitions. Expected value is going to tell us what we should expect in the long run on average if an event is repeated many times. And to calculate it, we simply multiply each possible outcome by its probability and add those. So here's an example with a spinner. You can see 3 is more likely than any of the other options. 4 is the next most likely, and 1 and 2 have the least likelihood of 1/8 each of the pie. So to determine the expected outcome, multiply the outcome times this probability and add all of these up, and we get the expected outcome is 2.875. Well, that makes sense because over half of the pie is 3. So we would expect that we're going to get something close to 3. All right, here's a more practical example. This is in insurance claims. If the claim is $0, probability is 0.70, 20,000, probability is 0.20, 20%, and so on. So what's the expected outcome or expected value for this? We're going to multiply each of the probabilities by their dollar amount, and when you add all of that up, you get $9,400. So the company can expect to pay $9,400 per claim in the long run. Okay, so if they want to break even, they'll charge their customers $9,400. They want to make a profit, they should add 50 to that and charge $9,450. Here's another example. Probability of dying at any given age. So this is a whole chart here with males and females at various ages. So a 30-year-old man wants to purchase a $300,000 policy. What should the insurance company charge him if it wants an expected profit of $100? Well, we have to think about how much the outcome is, one, that they pay, and the other outcome is that they don't pay. So that they pay, that would cost them whatever they're going to charge, X, minus the $300,000 they'd have to pay out, times the likelihood of that male dying. Then we're going to add to that what they get as a premium times the likelihood that the person doesn't die. And so it's 100% minus the likelihood they die is the likelihood they don't die. And we want that to equal a profit of $100. When you do all the math, it comes up to $559 for the policy. All right, here's a couple examples. You can click on these links here to get some other examples from the internet about expected value. And if you think this is something that sounds kind of interesting, you want to try to get some extra credit, I have a couple extra credit problems that are posted here. There's 1 and 2 there and 1 more on this last page. So good luck.